Utilizing Metallofullerene Nanotechnology for Cancer Therapy by Rishabh Mazmudar. The application of current chemotherapeutic drugs not only targets cancer cells but healthy cells as well. This results in detriment to patient health. After conducting research last year with gold nanoparticles, the underlying problem with cancer treatment still persisted. This ultimately led me to question, how can I selectively target cancer without hurting healthy cells? To find an answer to the question that has intrigued researchers for years, I looked to metallofullerene nanotechnology. Metallofullerenes are essentially carbon buckyballs with a metal particle inside. The buckyball structure is what is seen on everyday soccer balls. It's the pentagon-hexagon array with each vertice being a carbon. The metal particle in this case is iron. The iron inside forms ferrocene bonds with the outer carbons in order to bond with other metallofullerene nanoparticles. Naturally, these bonds form a double alpha helix structure, which is seen in this computer animated image. This key property is the reason I chose these nanoparticles. I applied these metallofullerene chains in both 95 and 99% purities at a nanoparticle to water ratio of 33%. The data I collected was done both qualitatively and quantitatively through the use of scanning electron microscopy and Raman spectroscopy. I found in the SEM images that there was a visible decline in cell count for all the cancer cell lines. However, in the healthy prostate cell line, there was no visible decline. In addition, I identified several instances of apoptosis, such as nuclear fragmentation seen here. See observations for all the images of all the cell lines. To support the qualitative data, I used conclusive numbers through the Raman spec. I found that at least 30% of cancer was eliminated in 24 hours for 2 cancer cell lines, and in 1 breast cancer cell line, 90% of the cells were destroyed. However, less than 5% of healthy cells were affected. I hope to validate my theorized microscopic effects in the future in order to have this turn into a 3-pronged approach of imaging, identifying, and eliminating cancer.